In the second part of Chapter 12, we're going to be looking at combinations, binomial probability, and normal distributions. So all these are very important uh, ways of determining some probability, and different from the first section that was more with simple probability. Now, we'll start out with a definition of what a combination is. We have two concepts. We have combinations and permutations. And a combination is where, think of it this way, I have a set of objects in here, and there are n objects in here. And I'm going to take a specific size sample out, but there's not going to be any replacement. So as I take one out, I'm not going to put it back in. And I want to know, say for instance, let's say I had 10 objects in here, and I wanted to sample and pull out 3. So maybe I pull out A, B, C. Maybe I pull out A, B, D, etc. And I want to know how many groups of 3 can I get from here. However, the order does not matter. So if I pull out A, then B, then C, we would not call that any different from C, then B, then A. So the order in which these are selected out does not matter. If it's a permutation, if you switch these around, the order does matter. But today we're going to be working with combinations. And how do we determine that probability? Well, there we go. We start out combination C. We call it N choose R. And it's a combination, meaning we have a particular number of objects we're going to pick out, and the order does not matter. So order does not matter, and there will not be replacement. And what we do is we take how many objects we have to choose from, how many we're choosing. And then the way of determining how many of these there are, we take what's called n factorial divided by this difference factorial divided by r factorial. Okay, and let's look at an example and we'll see exactly how to work with that. And remember that n factorial means that we take n times n minus 1 times n minus 2. We keep lowering down that integer until we finally get down to 1. Also, by definition, 0 factorial is 1. So we have this idea. We have 8 people, and we want to know how many pairs can be formed if we have 8 people. And we could go through and we could actually count them. We could say, here are our 8 people. 1, 2, 3, 4, 5, 6, 7, 8. And we could say, okay, let's see how many pairs we could form. Well, we could have this pair together, 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 this pair, this pair, this pair, this pair, this pair, this pair. There are lots of pairs. Now, if it's a combination, we don't care for how many pairs. I don't care if you pick A, B, or B, A. That's the same pair. So this is a combination, and we have 8 people to choose from, and we're picking pairs. We're picking groups of 2. And our technique for calculating that is to take 8 factorial divided by the difference factorial divided by 2 factorial. Now, this actually breaks down very, very nicely. 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which I'm just going to write like that. And I can see that these will reduce out. And the 2 factorial means 2 times 1. So this guy actually cancels that guy out. That 2 goes into that 8, and I know my answer is there actually are 28 groups. Now, next question. If there were 30 people, how many groups of 3 can be formed? If they are groups of 3, we know that we have 30 people to choose from. Sorry, I keep tipping this on an angle. We have 30 people to choose from, and we want groups of 3. So we have the 30 factorial on top, the difference between the two on the bottom, also divided by 3 factorial on the bottom. Now, we do have the calculator feature with factorials on our calculator. That is under the math and number, I believe, or math and probability. But be careful if you do enter this in. 30 factorial divided by, you do need a left parenthesis, 27 factorial, and then 3 factorial. You can put a time sign in there, but you don't have to. Truthfully, on ones that the choosing or the pulling out 3 is not very much, I quite often don't even use that button, because this means 30 times 29 times 28 times 27 all the way down to 1 divided by 27 all the way down to 1, so these are going to cancel. And then the 3 factorial is 3 times 2 times 1. And then I could do some division. This is actually 6. 6 goes into there 5 times. And I could multiply 5 times 29 times 28. And that would actually give me that 4,060. So again, you would have your calculator to do the calculations on these. Next one. We have lotto numbers. And we have a lottery that has 47 little ping pong balls in the machine, and it's going to pull out 6 of them. And we want to know how many different possible groups of 6 can be chosen. Now, the order in which you select lottery numbers does not matter. If you filled in little grid sheet and filled in 1, 2, 3, 4, 5, 6 versus 6, 5, 4, 3, 2, 1, that order does not matter. So this is a combination question. You're not putting the numbers back. You can't choose 1, 1, 1, 1, 1, 1. You don't have replacement. There are 47 to choose from, and we're picking groups of 6. There would be my factorial simplification, and it's nearly 11 million possibilities. So if you buy one ticket, you have 1 out of about 11 million chance of winning. Here's another little interesting way of looking at, if I have 20 distinct points are chosen on a circle, so I have a circle, and if I go around and pick 20 distinct points around here, and I want to know how many segments I would have, recognize any 2 pairs determine a segment. So this really is a combination of 20 choose 2. If I put 20 dots around this circle and then connect them pairwise, it doesn't matter if I go from this dot to this dot or from this dot to this dot. That's not going to be counted twice, so it is a combination. And I'd have 190 different values. Now, we can also throw in how many triangles can you form. And if I pick any 3 points on a circle, none of the 3, no group of 3 will ever fall on one line. They will always form a triangle. Therefore, my combination of 20 choose 3 will tell me how many triangles could be formed if I put 20 dots around this circle. Now, the last one on this sheet is going to help us look at how these combinations can be used to help us find some probability. So I have 8 people are chosen, or excuse me, 8 people are available to be chosen to be on a committee. And we have 5 men and we have 3 women. So we have 5 men, we have 3 women, and we're going to pick committees that have 4 people. First question is, how many committees are possible? We have a total of 8 people. The order in which you pick the people to be on your committee would not matter, and you're not going to replace anybody once you choose a person. So that is going to be a combination of 8 choose 4. So there are 70 ways or 70 different committees from those 8 people. Now, I want to find what's the probability that I look at those committees and I have all men on those committees. So now that it's a probability, we know we're going to have a numerator and a denominator. And if I think about it, I know that there are 70 different committees. That's how many committees are possible. And I'd want to look at all those 70 committees and count how many of them have all men. Well, this group of 5 people would be the only people who would be involved in determining my numerator. And there are 5 men to be picked from, and I would want groups of 4. So I would have a 5 out of 70 or a 1/14th chance, or 1/14th of my committees that would be randomly picked would have all men on them. Not a huge chance, but there is a chance of that happening. Now we want to find what's the probability that we would have 2 women on the committee. And the thing that we have to be careful about when we're figuring out probability questions with combinations is we have to make sure we choose everybody. We are picking 4 people. So this implies When I say I want 2 women on the committee, you want to find the probability of having 2 women and 2 men. We do want both. We don't just want 2 women because we won't have 4 people on the committee. And so look at our technique. Our denominator is the total number of groups of 4, which is the 8 choose 4, or 70. And we have to get our 2 women first of all. So from our little say bucket here, we have 3 women and we need to get 2 of these women. So that is combination of 3 choose 2. Keyword is and, times. I also have to get 2 men. There are 5 men to choose from. 5 choose 2. So it's the product of these two. I want 2 women and times I want 2 men. So I actually have a 3 out of 7 chance of randomly picking a group and it having two women and 2 men. Now we're going to switch gears, kind of, because there is going to be a connection. And you should recall what Pascal's triangle looks like. You worked with Pascal's triangle in Algebra 2. And in Pascal's triangle, remember, row 0 of Pascal's triangle was the good old 1. Oops, I'll try to get that on the screen. And then we have 1, 1. That is row 1. So we start with row 0, which is just the number 1. And then I have 1, 2, 1. And then I have 1, 3, 3, 1. And remember the idea that the outer part of the triangle is always a 1. And then we find every element inside by adding 2 terms down. 1 plus 2 is 3. 2 plus 1 is 3. I go to the next row, I'll have a 1 here and a 1 here. And then 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, etc. And I have my 5th row. And the row number will correspond with the exception of the 0th row, is going to correspond with this second value. Okay, now we have another characteristic in Pascal's triangle. I only wrote it down to the 5th row. But we do have, kind of interestingly, that if you take the sum of the terms in a row, sum is 1, some of these is 2, some of these is 4, some of these is 8, and so on, we do get that idea that we are getting a power of 2 for the sum. Kind of interesting. But for us, the context that we really want to see is each of these is a combination. This is a combination of 5 choose 0. So if I have 5 things, say I have A, B, C, D, E, I have 5 letters, and I say, I want to know how many groups can I get from these 5 if I don't pick any. Well, there's 1. You just don't pick any. 5 choose 1. 5 combination of 5 choose 1. I have 5 things to pick from, and I want to know how many groups of 1. Well, I can either have A, B, C, D, or E. So there are 5 groups. 5 choose 2 is 10. How many groups of 2 can I pick from 5? I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 groups of 2, and etc. So all of these values in Pascal's triangle are a combination. This value right here of this 4, this number is a combination of 4 choose 0, 4 choose 1, 4 choose 2. That is a combination of 4 choose 3. Okay. Now, another characteristic we want to see is we want to review what binomial theorem looks like. Now, remember, binomial theorem is a way of expanding down, and we'll write down the formula here in about a minute. But if I take x plus y and take it to the 0th power, anything to the 0th power is 1. If I take x plus y to the 1st power, I'm going to get x plus y, or 1x plus 1y. If I square x plus y, it's not just x squared plus y squared. We'd have to write it out twice and write it as x plus y times x plus y, distribute it out, and we end up getting this. Oh, 1, 1, 1, 1, 2, 1. If we cube this, it's not x cubed plus y cubed. Bad algebra mistake. Basically, if I take this previous answer and multiply it by x plus y, I end up getting this expansion. And I can see the trend. I can see Pascal's triangle. I can see that this x variable starts out to the 3rd power down to 2, 1, and cancels out 0. And the y term starts out to the 0, then 1st, 2nd, 3rd. and I can continue to expand. And remember, that's binomial theorem. And here is the generalization of the formula. The generalization of the formula says if you want to take a plus b and raise it to the nth power, I could have used x and y, but I have it as a plus b, that there are going to be three numbers. If I look at one of these individual terms, there are going to be three values that are going to help manufacture what our binomial expansion is. And there's going to be this first variable is going to be taken to an exponent, and the second variable is going to be taken to an exponent. Now this exponent is going to start out as a high number, and that will start out if I let this little subscript down here that says I equals 0. So I have from I equals 0 up until n, which is going to agree with this guy. I'm going to have a is going to start out being raised to the n power, and b is going to start being raised to the 0th power. And then my counter will go up, and this variable will start to get bigger, and this one is going to go down in number. We will also have a combination in front. It's going to have a combination of n choose, and then that's going to vary from n choose 0 to n choose 1 to n choose 2 to n choose 3, n choose 4, etc. All right, so we always have a combination of three things to make up each of our component, each of our terms. There will also be n plus 1 terms in our expansion. And this will be most easily done by going to an example and then looking back at the formula. So let's flip the page. And I flipped 2, so we don't want to do that. All right, and we're just going to go through basically part of this. And so if we want to expand this, I will specifically tell you that you have to expand using binomial theorem. And we'll look back at this notation in a minute. But this is going to involve, if I take the x minus 2 to the third power, I know that I'm going to end up having some type of a combination that is going to end up being the third row of Pascal's triangle. And I put 3, choose I, because this is going to change. It's going to start out as 0 and end up at a 3. And then I'm going to have this x term is going to start out to the third power, so this is a 3 minus I exponent. And then the negative 2 is going to start out to the I power. So that's our sigma notation for expanding it. But basically, once again, we need the third row of Pascal's triangle, which is going to be the 1, 3, 3, 1. Then we need to take this first variable, and he will start out to the third power, then to the second, then to the first, and then he will be to the 0th. This last number is a negative 2, and I'm going to put him in parentheses. He will start out to the 0th power, then he will come to the first power, then he will come to the second power, then he will come to the third power. And then each of these 4 terms has to be added together. Now in the end, this term is going to end up being negative, and this term is going to be negative. If you do have a negative value in between, you will have alternating signs. If this is a positive number, these signs will always be positive. Now you are not done at this point. You have to expand this out. So I have 1 times x cubed times, this is 1, so I have x cubed. Here I have 3 times x squared times negative 2. You must multiply those out. These coefficients add together, negative 6x squared. Next one, 3 times x times, and this is 4. And 3 times 4 is 12. And then my last term, 1 times 1 times negative 8 minus 8. And there's my expansion. I've also shown it here. Okay. Now we'll go down, and I'm going to skip. We're going to go down to this 8th one, and I'll get my paper here. And you could look this over. I've got the first 3 terms of that expansion, but let's just look down to this one. If I want to expand this, we are in the 4th row of Pascal's triangle. My sigma notation for it would look like this. I equals 0 to 4. There's going to be a combination in front of 4, choose something. Our 2x term is going to be there, and it's going to start out to the 4 minus I power. We're going to let I be 0 to begin with, and this will start out to the 4th power. This is all multiplied together. And the last term is a negative 1, and he is going to start out to the I power. He's going to start out as a 0, and that sigma means we're going to be adding them all up. There actually are 5 terms. First thing I do would be to get the 4th row of Pascal's triangle, which is 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4, which is the 1, 4, 6, 4, 1. And then remember, the next thing is this 2x in parentheses. It's going to start out to the 4th power. Then he's going to go down to the 3rd, put it in parentheses, to the 2nd, to the 1st, and to the 0th, and I'm not going to bother writing down the 0th. Likewise, this negative 1 is going to start out to the 0th power. I won't bother putting it down. I'll just put the plus sign. Then he's going to be to the 1st. Then he's going to be to the 2nd. Then he's going to be to the 3rd. And then he's going to be to the 4th. Expand this whole thing out. 1 times, this is 16x to the 4th. This is 4 times 8x to the 3rd times negative 1. That will give me negative 32x to the 3rd, and so on. We'll expand this all out. And when I do that, this is what I get from my final response. Okay, and this is related to probability, and that's what we'll be working on tomorrow. So now you're ready to practice on your worksheet.